Gemini backs down from an Atari chess challenge. Scientists discover the point where AI makes the leap to understanding meaning. The emergence of AI slop threatens to drown out good content. And Amazon may have a unique and profitable strategy for the internet gold rush. Welcome to Hashtag Trending on a day full of AI-related stories. I'm your host, Jim Love. Let's get into it. Google's Gemini AI officially backed out of a planned chess match against a 46-year-old Atari 2600 chess engine. After initially claiming it could dominate the vintage console, Gemini reversed course, admitting it would struggle immensely and calling cancellation the most time-efficient and sensible decision. The match was part of a series of lighthearted but revealing tests by Citrix specialist Robert Caruso, who previously challenged ChatGPT and Microsoft Copilot with the same Atari system. Both of those systems lost badly, and Gemini seems to have learned from their mistakes. Early on, Gemini confidently described its ability to evaluate millions of positions and even suggested it could beat human chess masters. But when reminded that the Atari chess engine runs on 128 bytes of RAM and a 1.19 megahertz chip and still outplayed its AI competitors, Gemini reconsidered. After re-evaluating the match, it acknowledged it had been hallucinating about its own capabilities. Now, this isn't really about chess. It highlights the difference between large language models like Gemini and purpose-built chess engines. LLMs are trained on language, not logic trees or game strategy. And there's another lesson in this. We tend to think of AI as the answer for everything, but at least for now, there appears to be times when a rules-based algorithm is faster, more accurate, more reliable, and, above all, cheaper. Or as one AI observer puts it, sometimes the smartest move is knowing when not to play. Researchers think they've found the precise moment when a language model starts truly understanding the meaning of words and sentences. It was a joint team from MIT and EPFL, the Swiss Federal Institute of Technology, and Lausanne, and it discovered that as transformer models are trained with more and more data and more connections built up in their neural networks, at some point they go through a sudden, measurable shift. Early in the training, the models rely heavily on structure, things like syntax, word order, position, and sentence structure. But after being exposed to enough text, they abruptly start appearing to understand the meanings of words themselves, switching from syntax, the mechanical structure and position, to semantics, the actual meaning. It appears that this is not a gradual evolution. It's a sharp transition and a sudden change in state, compared by the researchers to something like where water, after raising its temperature, suddenly reaches a boiling point and turns into steam. They call this a phase transition, and they say it happens in physics all the time. In AI models, it appears that a similar thing occurs. In the training process, the model builds internal representations called embeddings. At first, these embeddings reflect mostly where the words appear in sentences, and the model gets better and better at predicting by word position and structure. But once the training data passes that certain threshold, the model re-encodes the embeddings based on how words relate to each other semantically, not their position, their meaning. And you can spot this because the model starts grouping words with similar meanings that may be far apart, and it puts them closer together in the model. For example, cat and dog might become related in the model's internal map regardless of their position in the text. The breakthrough, published in the Journal of Statistical Mechanics, might lead to big changes in how large language models are designed and trained. AI researchers know that increasing the amount of data has had a positive impact on the intelligence and utility of the model. Part of this experiment will explain that. But if we extend the parallel to a physical phase shift, is there a point at which adding additional data has lower or perhaps no additional impact on the model's abilities? Is there a point at which it will hold the model back? It suggests that exposing a model to just enough data to reach this phase change may be more efficient than simply throwing more and more data at it. But it also gives researchers a start at one of the great questions of our time. AI researchers will tell you, we really don't understand what is happening in these models. And with this theory, we might be on our way to, for want of a better phrase, understanding how AI begins to get language, not just at the output layer, but deep in the structure of how it thinks. We all know that AI can create content faster than anything we've ever seen before. But creating it is only one step. Somebody has to review it. And across all industries, the people responsible for that work are drowning. In academia, researchers are overwhelmed. A recent report in The Guardian shows that the number of scientific papers published has exploded in the last decade. In academia, researchers are overwhelmed. A recent report in The Guardian shows that the number of scientific papers published has exploded in the last decade. But many of those papers are of low quality, and some are clearly generated by AI. One AI-written paper about a rat with an anatomically impossible feature was accepted, published, and only pulled after readers complained. The peer review system, which relies on experts volunteering their time, simply can't keep up. In cybersecurity, it's the same pattern. Organizations run bug bounty programs, offering cash to people who find security flaws in their code. But Daniel Stenberg, the creator of the open source tool curl, said he's being buried in low-effort bug reports, many clearly written by AI. The reports are often vague, misleading, sometimes just wrong, and each one has to be reviewed. And that takes time away from fixing real vulnerabilities. In publishing, the amount of books published by Amazon's Kindle Direct Publishing has more than doubled in the past 5 years. Amazon is struggling to cope with a tsunami of low-quality content created by AI. And that, they feel, might be drowning out the great content. This is a pattern that's being repeated over and over, and not just in text-based content. Some are complaining that YouTube is being flooded with low-quality AI-developed content, particularly since video and podcasts became so easy to generate with AI. Some worry that the internet itself may collapse under the weight of low-quality AI-generated content. There's even a term for it. It's called AI slop. The message is clear. AI makes it easy to quickly generate unlimited amounts of content, but it takes real skill and human effort to make that content useful and valuable. When the floodgates open, the overwhelming wave of not even bad content, but just content that's not very good, can crowd out the excellent. It wastes the time of the people we rely on to keep systems trustworthy and secure and the content valuable. And it risks turning off people who are looking for exciting, entertaining, and informative content. In the Klondike Gold Rush, more than 100,000 people set out to strike it rich. Most never made it all the way to the Klondike. Only a tiny fraction of those found any gold at all. But you know who really profited? The ones selling picks and shovels. And Amazon seems to be taking the same approach with AI. Reports say that the company is preparing a second $4 billion investment in Anthropic, bringing its total stake in the Claude AI developer to more than $8 billion. But unlike Microsoft and Google, Amazon isn't really pushing a flashy consumer chatbot or talking about AGI. It's selling the infrastructure that runs that AI. Anthropic trains its models on Amazon Web Services using Amazon's own Trainium and Inferentia chips. And that's already turning into serious revenue, especially with Anthropic's focus on enabling business processes with its specialized models for specific verticals and segments. Business Insider reports that Anthropic could bring in over $1 billion in AWS revenue this year, with more than $5 billion annually by 2027. And Anthropic itself shares a similar philosophy. Instead of being all things to all people, it is focused on finding areas where its AI can have the biggest impact in terms of automating and transforming specific business processes and verticals. This week, it announced it'll be providing a new offering aimed solidly at the investment industry, one that is eagerly anticipated and which has huge opportunities in terms of creating and managing research and support services. So by backing Anthropic, Amazon isn't just investing in a startup. It's acquiring a tool that is a showcase for AWS and quietly positioning itself as the company that powers the AI revolution, regardless of which model wins. And in doing that, although it's investing billions of dollars, most of that investment is in the form of processing cycles, largely on its own chips and in the data centers it needs to build anyway to support the AI-driven growth in its hosting business. It isn't sexy, but neither was Amazon's first strategy of building capacity early when cloud computing was in the initial stages, a move that ran counter to what everyone else was doing and thought of as very risky. But that strategy made them the biggest hosting company in the world, both in market share and revenue and profitability. So they might be on the verge of pulling this off for the second time after the gold rush. And that's our show. I try not to do a full program on one topic, but there were just so many AI stories that deserved attention over the past few days, I felt I had to run with them. If you were particularly interested in today's stories, you might want to tune in on the weekend when we do our Project Synapse show, where we'll be doing a deeper dive into these stories and more. I'm your host, Jim Love. Have a thrilling Thursday.